In this video, we are going to use polar coordinates to do an integral. Find the volume under the surface z equals x squared plus y squared, and above the disk x squared plus y squared. This should be less than or equal to 9. When doing this, it's a good idea to sketch what the region of integration is. So the region of integration is going to be the circle of radius 3 centered at the origin. So the function that we're integrating is going to be over the region R. I'm going to call this the region R. And we're integrating x squared plus y squared. And I'm just going to write dA as a generic double integral volume element. We could do this using rectangular coordinates, and maybe the inner integral would be the y integral, and that would go from minus the square root of 9 minus x squared up to the square root of 9 minus x squared. And then x would go from minus 3 to 3. But since we're integrating over a circle, it makes more sense to do this in polar coordinates. So using polar coordinates, here's sort of the procedure. So you need to figure out which variable is going to be the inner integral. I typically like having r be the inner integral and theta being the outer integral. Now, since we're integrating over a whole circle, theta is going to go from 0 to 2 pi, and for every fixed value of theta, r is going to go from 0 to the boundary of this circle, which is 3. R goes from 0 to 3. The function that we're integrating is x squared plus y squared. That's equal to r squared in polar coordinates. And then in polar coordinates, dA is equal to r dr d theta. And so now we're integrating theta equals 0 to 2 pi, r equals 0 to 3, r cubed dr d theta. If we do the inside integral, this is the integral of theta equals 0 to 2 pi. The antiderivative of r cubed is r to the power of 4 over 4. And we're integrating from r equals 0 to r is equal to 3. And this is just equal to pi over 2 times 3 to the power of 4. 3 cubed is 27. 27 times 3 is 81. And so this is 81 pi over 2. Find the volume under the surface z equals xy, and above the disk x squared plus y squared equals 9 in the first quadrant. So again, let's sketch the region of integration. Also, this should be less than or equal to 9. So the region of integration is going to be the quarter circle or the quarter disk of radius 3. So the integral, again, I'm going to have the theta integral on the outside and the r integral on the inside. So in this problem, theta is going to go from 0 to pi over 2, because we only want this quarter circle. And for every fixed value of theta, r is again going to go from 0 to 1. 0 to 3. The function that we're integrating is x times y. In polar coordinates, this is r squared cosine theta sine theta, and then whenever we do polar coordinates, we always write the r dr d theta. This is the integral theta equals 0 to pi over 2, 1/4 times 3 to the power of 4 cosine theta sine theta d theta. And now we can do u substitution. So remember from the previous problem, 3 to the power of 4 is 81. So this is 81 divided by 4. Now for the integral, I'm going to say that u is equal to sine theta, so that du is equal to cosine theta. So the integrand becomes u du, and the limits, if theta is 0, u is sine theta, so that's equal to 0, and sine of pi over 2 is equal to 1. And so this is 81 divided by 4 times 1/2. This is equal to 81 over 8. So the new thing in this integral is that theta didn't go from 0 to 2 pi, theta went from 0 to pi over 2.